Hey, it's Samsi here, and I am back with my second video. In this video, I will be discussing with you the top 5 tips on what makes a good machine learning project. I have organized these tips in such a way that it would maximize your learning to help your portfolio stand out and not look so generic to employers. As someone who has also had to go through the process myself, not having a very strong degree, like computer science degree, that is like more ideal for the job market. So I hope you find these tips useful. Plus, at the end of this video, I will also be evaluating Kaggle against these tips to see how it compares. So let's get started. So tip number 5, domain knowledge. It is preferably good that the project you're working on gives you like expertise in a specific field within machine learning. So for example, you can decide to master the dark arts with NLP or go into a more homogeneous field and try to like be an advocate for AI and diversity, take on computer vision, yeah. Or you could decide to like mess around with time, do something more complex like time series analysis. And I say this because I am a big master of one person than learning bits and pieces of something, because if you are good in one area and you focus on one area, it helps to build confidence. And if you're engaging with a specific job spec that is like looking for somebody who knows NLP, you could like really do a nice pitch for yourself and you could be more confident with that area. Ideally, you should want to like love, already have a passion for that specific domain that you are wanting to venture into. So yeah, it is good to know something very, very well. Confidence boost. Tip number 4, an opportunity to apply a simple algorithm and a complex algorithm. Yes, I say this because of the free lunch theorem. Averaged across all problems, not one single machine learning algorithm is better than the other. And you need to know why, and you need to understand this. Being a data scientist, you always need to like know what is the most appropriate method to apply for a certain scenario. So if you can already exercise these different types of scenarios with your project, it'll be great for your knowledge and understanding. Yeah. Especially if you're working in industry where you need to produce things at a quick rate, quick time, you already need to have a certain idea of, okay, what algorithm should I actually try for this specific data set? And I want to talk a little bit more about this, so I guess I am. So for example, a deep learning algorithm really loves a lot of data. And if you only have like 30 data points, this knowledge will help you say, actually, no, I should not try a neural network and rather go for a statistical learning method. Yeah, and you need this knowledge. So yeah. Great point. Tip number 3, the element of data collection. Most data that you get in the real world is never clean. It's usually raw, coming from a system that's like ancient, and you're gonna have to work with messy data a lot in industry. So chances are that if you collect your own data in your own project, it's more representative of the real world, and you will experience a lot of pain points that comes with working with messy data. And as well as you might not actually have data, and you have to be creative on where you're going to get data and think a lot about what data you need. So if you have a project that allows you to really exercise this, I think it's quite impressive, and it shows a lot of character, and people will be impressed by this. Namaste. So tip number 2, high-dimensional data. So machine learning algorithms or problems feed off a lot of data, variables, and features, and how these work together and interact with each other. And most of these variables are like used to explain the target variable that we're trying to predict. And sometimes it's like the more variables you have, the better. The more important variables you have, even more super, you can get more accurate results. So part of the data science job is to actually identify useful features and also identify how to combine certain features together so they are more useful. And if you have a project that can already allow you to exercise a lot of these algorithms, and even algorithms that help you to like reduce the dimensions of data, like PCAs and clustering, especially for like very computationally expensive algorithms, you'll be a more efficient and better data scientist. Feature engineering is like essential. Tip number 1, make sure that the problem you're solving is relevant. So when I was starting off as a data scientist, I thought relevant meant that, oh, I have built a good fake news classifier. It is accurate by 94%. I am genius. But no, that is not a relevant problem. A relevant problem is something that impacts someone, something, somewhere out there. Like it is either saving money, lives, time, contributing to like open source, something of that sort. And I recently came across a paper that talked about machine learning that matters. And I would advise you to read this paper because it gives you advice on how you can structure your problem so that it matters. So for example, the problem I gave you now about building a nice fake news classifier, you could actually like change that into something that's saying that, oh, for example, in Africa, there's a lot of fake news spreading that's having a negative impact on people. And it's like making people vote for like bad politicians. And you could frame your problem in such a way that you are trying to improve more positivity and like improving democracy. Like you could phrase it in a way that it makes the problem actually matter and contribute something. So that is my number 1 tip. As promised, I said that I was gonna compare how Kaggle fares out against these 5 tips I just discussed with you. If you have not heard of Kaggle yet, Kaggle at the moment is the biggest website that hosts machine learning projects. They have tons of data sets. Companies can open up a competition and like anyone can enter these competitions and compete. And usually the ultimate or winner is one who has the highest accuracy score based on the matrix that the company is measuring them by. That's in summary what Kaggle is. So let's start with tip number 5, which was domain knowledge. I do believe that Kaggle ticks the box for this one because there are a variety of different projects on Kaggle, from computer vision to machine translation to like time series analysis that you can decide to take on. So you can do bits and pieces of different types of competitions and projects there that will give you this experience. Number 4 was the opportunity to apply a simple algorithm and a complex algorithm. I would say, yes, Kaggle ticks the box for this one because you could pretty much do whatever algorithm you want to use. But there are specific problems where deep learning is more encouraged as the preferred method, like computer vision and machine translation. So that will be a little bit separate. If you want to focus on one specific data set where you can apply different things, there are data sets there that allow you to do that. So number 3 was the element of data collection. Most of the data on Kaggle is already provided by companies who have most likely scrutinized the data, have already thought of what variables they want and need, and you don't have to do much thinking about that. So I would say that Kaggle falls short in this one. And even the way you retrieve data from Kaggle, it's very simple, and there's not a lot of like joining and mashing and cleaning of data that you would have to mostly apply in real life. It's less representative of the process that you would go through in real life when you are gathering data. So yeah, falls short. We give it an X. Point number 2, which was high-dimensional data. Yes, Kaggle does win with this one in the sense that you do have the option to enter competitions or try out projects that have lots of variables. So you could play around there, and you can play around with PCAs, clustering, feature engineering. Yeah, it gives you that opportunity. So we gave it a tick for this one too. Now, point number 1, which was the problem must be relevant. In most Kaggle competitions, the problem is already defined for you. They tell you what you need to predict, and you don't have to do much thinking about that. All you have to think about is the algorithm and optimizing for that specific data set and that specific matrix. So I think Kaggle stops a lot of data scientists who are only focusing on Kaggle to think beyond the algorithm, to actually think about how is my answer, how is my solution going to actually impact people, how is it going to impact society, and Kaggle removes that thinking away. And this is something I really hope that many data scientists have recognized about Kaggle. It is a good learning platform. It is good to practice algorithm. It's good to get comfortable with applying specific methods to data sets. But when it comes to formulating a problem and understanding real life or systems thinking, how things interplay in the sense. Just need to be a little bit of just be a little bit more mindful that it does not give you that opportunity. And that's it for this video. I hope you have liked it. If you have anything to add on to what I have just said right now, or if you disagree with any of this, please feel free to comment. And if you have really liked it and agreed with everything that I've said and you're like, yeah, you were right, please give me a like. Plus, if you don't want to miss out on any of my content, you can subscribe to my channel, as well as don't forget to hit that notification button. I would also like to thank my Patreon backers. Without your support, these videos would not be possible, and in the future, I would really like to improve the quality of these videos, as well as produce more content. So the more Patreon support I get, the more you will also get back. So if you want to find out how to support me via Patreon, the link is right here below. Don't be shy to click on it. Bye.